Welcome back. Today's topic is Ohm's law. In the last lecture, we have discussed about the common electrical engineering terms. We have gone through the definitions of current, the potential, the energy, and power. And we have also seen the three commonly encountered network elements R, L, and C. And we have also compared the properties of these elements in the last lecture. And in this lecture, we will discuss about Ohm's law. You might have come across this Ohm's law in your +2, but we will have a quick revision and we will see simple problems on Ohm's law. I hope that by the end of this lecture, you will be able to state Ohm's law and also compute current, voltage, and power in simple electric circuits. So, before I start with the Ohm's law, let's have a quick recap of what we have gone through in our last lecture. I have told you in the last lecture that whatever the components which are present in a network are called as network elements. So, let me start with the classification of network elements, after which I will move on to Ohm's law. So, I will start with the classification of network elements and then we will go through the Ohm's law and then we will solve simple problems on the basis of Ohm's law. So, the first part of today's lecture is classification of network elements. So, any elements you find in the network is called as network elements. We have seen that there can be sources, current and voltage sources, dependent and independent. You will come across them. There can be RL and C, there can be diodes, there can be transistors. So different elements are present. All these are generally considered as network elements. So now, how to classify these elements? There are different classifications of these elements. The first classification is linear and non-linear elements. So what do you mean by linear and non-linear elements? If the VI characteristics, it is defined by the VI characteristics. Let us suppose there is an element and I am applying some voltage across it. Some voltage has been applied across it. And automatically when a voltage is applied across it, automatically what happens, there will be a current going in the circuit. If I increase the voltage, the current may increase or decrease. It may increase linearly or it may increase exponentially, or sometimes after some time it may go into saturation. It depends upon the type of element, isn't it? So, as V increases, I may decrease or increase, or it may go to saturation, or it may increase exponentially. It is the nature of any element, right? If the relation between V and I, if it is linear, which means if V is increasing, I is also increasing, whether it is in a linear fashion or maybe exponential. If it is increasing, if this is also increasing, then it is termed as a linear element. And if it is not increasing, or maybe it is not continuous, let us suppose after some time it is getting saturated, or after some time it is just coming back to Z, or after some time it is suddenly moving into negative. So if this is the case, then it is called as a non-linear element. So if the VI characteristics are linear, then it is called as a linear element. If it is non-linear, it is called as a non-linear element. Examples of linear elements are resistors, inductors, and capacitors. So your R, L, and C, they come under linear elements. These diodes, transistors, thyristors, thermistors, etc., they are considered as non-linear elements. The next classification is unilateral and bilateral elements. So now let us suppose now if I am drawing I and V, right? Now let us suppose if V is increased, then I is also increasing, let us suppose. Okay, if V is applied in a negative fashion, then I also must be in reverse direction, isn't it? If let us suppose, which means the slope will be in negative direction. Or there may be cases for some elements, if I increase the V, I also will be increasing. But if I decrease the V, then automatically the current will remain 0. So this is my characteristic. So there are two different types of elements if you carefully observe. Even if the direction of V is changed, the characteristics are not changing, they are linear only, which means if the current direction of V is changing, direction of I is also changing. But here, if you carefully see, if the direction of V is changing, automatically what happens? The current is displaying a different characteristics when compared to the initial one. This type of elements are called as unilateral elements, which means that they will work in only one direction. Whereas these type of elements, they are called as bilateral elements. Example of unilateral elements is diode. You might have come across this diode, forward bias and reverse bias, right? In forward mode, if I go on increasing the voltage, the current will be slowly increasing. But whereas in a reverse direction, if I apply voltage in negative fashion, then there won't be any currents. So which means that the characteristics take different. Characteristics will be different for both the things. So these type of devices are called as unilateral, whereas R, L and C, they are considered as bilateral. So if the voltage direction or the current direction is reversed, then automatically the corresponding voltage and current also, they will get reversed. And another classification is the active element and passive elements. As already said, some elements, they tend to Q. They tend to act as a source. They tend to provide energy to your circuit. Such elements are called as active elements. Your voltage source, current source, etc. They are generally termed as an active elements. Whereas some elements, they try to absorb the power or dissipate the power. Those elements are called as passive elements. Your R, L and C, as we have seen in the last class, those are basically passive elements. They consume power. Whereas the sources, they provide power. So whichever element is providing power, or which has the capability of increasing the level of signal energy, then it is called as an active elements. If it is observing, then it is called as passive elements. So now I hope that you have understood what actually the classification of elements is, what actually unilateral bilateral elements are, what actually active and passive elements are, and what actually I started with linear and non-linear elements, and then we moved on to unilateral and bilateral elements, and then we have discussed this active and passive elements, isn't it? Now, in the next slide, we will discuss about the Ohm's law and what is its significance, and later on, we will try to solve problems based upon Ohm's law.